that we've talked about reference angles, we're going to take a look at evaluating trigonometric functions for any angle theta. So the steps to do that is to find the reference angle theta prime. Then step 2, you're going to evaluate the trigonometric function for theta prime. And then step 3, you're going to determine the sign of the trig function value from the quadrant, depending on where theta lies. So first of all, let's talk about the signs of function values. It depends on what quadrant that the angle ends in, and that'll tell us whether or not it's positive or negative, depending on if we're given sine, cosine, tangent, or the reciprocals. So first, let's take a look at quadrant 1. Looking at quadrant 1, we want to know the signs of sine, cosine, and tangent. So if you remember this quadrant 1, we want to know what signs, first of all, are the x and y value. So the x in this quadrant is positive, right? The x is positive and the y is also positive. So really important to know that anything in quadrant 1, everything is going to be positive. So sine, cosine, and tangent. Then if we take a look at quadrant 2, let's take a look at the signs here. So the x value in this case, x value is going to be negative. And the y value in this quadrant is positive. So remember, negative, the first value is x, and then this is our y value. So sine, remember that sine is y. Sine is our y value, so therefore it's positive. Cosine is our x value, and it's negative. Tangent is sine over cosine. So sine, it's a positive, over a negative, that will yield a negative. So therefore, tangent is negative in this case. So we'll go ahead and erase that here. So tangent is negative. Let's look at quadrant 3. So in this case, our x value is negative and our y value is also negative. So x is negative, y is negative. Therefore, sine of theta is negative. Cosine of theta, our x value, is also negative. Then tangent is sine over cosine, y over x. So therefore, this is positive. Now let's look at quadrant 4. So in this quadrant here, the x value is positive, and the y value in this case is, the y's are negative in this quadrant. So therefore, sine of theta is our y value. It is negative in this quadrant. Cosine is positive. Tangent, again, that's sine over cosine, so negative over a positive. That means it is negative in this case. Now there is a pattern to this. So notice that in this quadrant, everything is positive. So this is all. So I'm going to call this A for all. In quadrant 2, sine is the only one positive. Sine is its reciprocal. So S for sine. In quadrant 3, the only one that's positive is tangent. So that is T. Then for our quadrant 4, the only one that's positive is C here. So going in from quadrant 1, 2, 3, and 4, it is A, S, T, C. So this is a way to help you remember what sign it is depending on what quadrant it ends in. So this is A, S, T, C. A stands for all positive, S stands for sine, T stands for tangent is positive, and C stands for cosine. Now something to kind of help you out with remembering that is A is all, S is students, T is take calculus. So all students take calculus. Knowing that will help you in determining the sign of the function depending on what quadrant it lies. Now, one more thing that we need to do is we are using the unit circle to evaluate these functions, and so it is very helpful to have your unit circle. Now I'm going to show you a shortcut of how to fill this out. So in case you don't have a unit circle and you want to fill one out, you don't have it memorized quite yet, here's one way to fill it out. So you really just need quadrant 1, because once you find out the reference angle, everything is going to be referring back to this. So hopefully you did that practice of filling out a unit circle, and then you see that it is all related. Now, let's fill out degrees first. This is 0, this is 30, 45, 60, and 90 degrees. Then we know that this is also 0, and then at the 90 degrees, that radians is pi over 2. Then hopefully you remember to convert it, so you can convert these 60 degrees times pi over 180 degrees. You're going to get pi over 3. This is pi over 3, and then this one is pi over 4, pi over 6, and then this is also 2 pi. So notice that it goes backwards here. This is pi over 2, this is 3, 4, then 6. It's not 5, it's 6. And then all the way down to 2 pi here. Then we know that this point here on the unit circle, the x value in this case, x is 1, and the y value is 0. X is 1, y is 0. And then all the way at the top up here, the x value now is 0, and y is a positive 1. So from our quadrantal angles. Now it's these other stuff in the middle. Okay, so let's fill out the degrees in this case. This is 0 degrees. Then we have it here, 30, 45, 60, and 90. So let's fill it out. 30, 45, 60 degrees, and 90 degrees. Sine is our y value, cosine is our x value. So the only thing that you need to start with is you can start filling this out. You know the degrees. You start with sine, the y value. What is the y value at 0 degrees? And that is 0. So that's all you need. And then let's do a pattern. This is 0, 1, 2, 3, 4. Then we go backwards. 4, 3, 2, 1, 0. Next, you square root everything. Then last, well, not almost last, you divide everything by 2. Then you simplify. So therefore, square root of 0 over 2 is 0. Square root of 1 over 2 is a half. Then square root of 2 over 2 stays. Square root of 3 over 2 stays. Square root of 4 over 2. Square root of 4 is 2 over 2. Therefore, this is 1. Then it goes backwards, right? Square root of 4 over 2, that is 1. Square root of 3 over 2 stays. That stays. This is 1 over 2, and this is 0. So knowing this, now that we have this table, we can refer back to it, and we will. We know that, number 1, our y value is 0 here. Y is 0. So then you go backwards and fill it in. So therefore, this is a half. At 45, that is root 2 over 2. Then here is root 3 over 2, and then notice it's 1 at the top. Another pattern you can notice is this is 0, 1, 2, 3, and this is our 4, and then it's going to go backwards. This is 0, then it's going to be a half, root 2 over 2, root 3 over 2, and then 1. So notice that pattern, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. The 45 is really nice because it's the same exact value. So here is our first quadrant. Everything is going to refer back to that. Then we look at the sign. So we're going to use that. So let's use reference angles to evaluate functions. So we don't use calculators. This is a non-calculator portion. So we're going to evaluate tangent of negative 240 degrees. Now at this point, it's really helpful to draw your reference angle. So we know that the angle, if it's negative, it's going clockwise. Remember, this is negative 90, negative 180 degrees, and negative 270 degrees. So negative 240 means it's going to end up here, which is quadrant 2. So remember A, S, T, C. So sine is the only thing positive here. So what that tells me is at the end, whatever answer I get is going to be negative. Okay, so that's number 1. So this is negative 240 degrees. Now we need to find the reference angle. So our reference angle is always towards that x-axis. So how far is this negative 240 from the 180 degrees? So then you just take 240 and 180. It takes 60 degrees to get there. So that is our reference angle, 60 degrees. So we're looking at tangent of 60 degrees. Tangent, if you remember, is y over x. So let's go to this table here. Tangent of 60 degrees. Y is root 3 over 2 and x is 1/2. So we're going to write that here. Root 3 over 2 and x is 1/2. This is our y value on top and our x value. Then we simplify. Square root of 3 over 2 divided by 1/2. Remember that you flip and multiply when you're dividing by fractions. So therefore, the final answer, and we already said it's negative, is going to be square root of 3. So that is how you evaluate the function. So before we get to the radians, go ahead and try number 9, cosine of negative 210 degrees. As a hint, sketch it out first. See if you can find it, and then use the table to help you out in referencing the signs. So if you tried this out, you would find that it ends up in quadrant 2 at negative 210 degrees. So the reference angle is 30 degrees. Now the x value in this case, which is our cosine is negative because we're in quadrant 2. So therefore, then you have to look at what is cosine of 30 degrees. So cosine of 30 degrees, so looking at this table, cosine of 30 degrees is root 3 over 2. The next video, I'll go ahead and cover how do you solve in radians.